Hello once again, this is the Pencrest High School AP Physics 1 video series. This is video 9F, DC circuit problem solving strategy. Now most of the analysis of DC circuits involves the use of Ohm's law. Ohm's law is V equals IR. V is the voltage, I is the current in amps, and R is the resistance in ohms. On your formula sheet, it looks like this. Current, or I, equals delta V over R. We would describe the delta V as the voltage drop across a given resistor. Now typically what we want to do is reduce a complicated circuit to a single equivalent resistance, which effectively tells us what the entire circuit feels like to the battery. This allows us to find the total current provided by the battery, which we call I sub t. We may see combinations of series and parallel circuits in the same circuit. For example, we have one here. Here's V sub t, the battery. We have R sub 1, R2, 3, 4, and 5 in this particular arrangement. Now we want to take this whole circuit and reduce it to a single equivalent resistance. We can see that 3 and 4 are in series, but that series combination is then in parallel with R2, and then this entire parallel combination is then in series with both R1 and R5. So we have to approach it in pieces. So the first thing we're going to do is use the series circuit rules to replace R3 and R4 with an equivalent resistance for those two, which we'll call R34. So 3 and 4 are in series here. We're going to add them and then replace that series combination with R34. Then we can see that R34 and R2 are in parallel, so we're going to use the reciprocal arrangement, and we're going to replace 2 and 3,4 with a single resistance, which we'll call R234. Now this resistor effectively replaces the entire parallel circuit here. Then we can see pretty easily that R1, R2, 3, 4, and R5 are in series. So the equivalent resistance of the entire circuit, we just add them all up. So now we have an equivalent resistance, REQ. We use it to find the total current coming from the battery. I sub t equals VT over R equivalent. And then we got to go back and apply Ohm's law to each section of the circuit independently. So the first thing we want to look at here is if there are any resistors in series with the battery. In this case, R1 and R5 are in series with the battery, and we know that the total current in both of those cases, the only option it has is to go through R1 and then through R5. So whatever we get for IT is also the current through R1 and the current through R5. So then we can use the current in each individual resistor. We use Ohm's law to find the voltage drop across each one. So in other words, the voltage drop across R1, V1, equals IT times R1, and V5, or the voltage drop across R5, equals IT R5. Now 2, 3, and 4 are a little more complicated, but we can do it in steps. We know that this is a parallel circuit that itself is in series with 1 and 5. So when we look at this particular step, this simplified version, where we've replaced 2, 3, and 4 with an equivalent resistance R2, 3, 4, we can then say that the total current has to go through this resistor. We can use that total current and its equivalent resistance R234 to get the voltage drop across this part of the circuit. So the voltage for 2, 3, and 4 equals the total current times R 2, 3, 4. Now we know that the voltage is the same across each branch of a parallel circuit, which means that R2 gets V2, 3, 4, and then the combination of 3 and 4 get the voltage drop 2, 3, 4 also. So first we'll do R2. We'll find its current. We know its voltage is V2, 3, 4. We divide by R2 and we get the current through R2. The 3 and 4, a little harder, but we see that 3 and 4 are in series inside the parallel circuit. When we look at the simplified version with 3 and 4 replaced with a single resistor, we know the voltage across 3 and 4, which is V2, 3, 4. We can then get the current through this branch of the circuit using the voltage for 2, 3, and 4 and the equivalent resistance of 3 and 4. That'll give me the current. I'm going to call it I34 because resistor 3 and 4 are in series, which means each of them will have the same current. We're then going to use that current to find the voltage drop across 3 and the voltage drop across 4 independently or separately. The voltage across 3 is I34 times R3, and the voltage across 4 is I34 times R4. Again, same current, different voltage. Okay, to summarize, first we replace the entire circuit with our equivalent using whatever combination of series and parallel rules we need. We then use that equivalent resistance and the total voltage from the battery to determine the total current coming from the battery. We then look for any resistors that may be in series with the battery, in which case they get the total current. And then 4, we apply Ohm's law to each resistor in the circuit one at a time. Okay, that's our problem solving strategy. Next up is electrical measurement. Until then, enjoy, and I'll see you again soon.